Hello everyone, C programming, session 3. In the last session we have shared that information about the variables, different variables, integer, float, character, short, unsigned, float, double, all those variables we have seen. Now we can, in this session we are going to see about that storage class of the variable. Storage class basically, storage class is the one which decides the scope, visibility and lifetime of the variable. Basically is a scope in the sense whether in at which location that variable can be accessible, whether that variable is visible to that inside the function or not, and whether that the content of the variable will be lost once it was done or it will be available over the period of time. All those things will be decided based on the storage class. Basically the storage classes are different. Storage classes of the variables are global variables, local variables, static variables and register variables and extern variables. Now we can see about the global variable. Global variable is the one declared outside the function, which is available over the entire program. Value can be changed by any function and can be initialized with a value. The uninitialized global variable will be initialized with the 0, and the initialization process will happen before main function, so that when we print the global variable it will be a 0 basically. Now we will see, we can open a file called vim global.c. I am going to use this include stdio.h and integer main integer or c comma character star or b. This is the default format, and return 0. I am going to use a variable called integer global. I have not done any initialization. I am going to print inside this function printf. To print an integer we should use %d /n comma global. Now we will see that the result gcc-o global.c, and when we run we got the value of 0. That it was initialized with the 0. Maybe to get more clarity we can do that. I am going to initialize this variable with 45, so that now we can able to see I am getting 45. Basically that the global variable is the one that variable will be get initialized before the function call of main. Basically it has two different types, uninitialized and initialized variable. For example, global, if you does not initialize integer a, now we have two variables. A is the one which is uninitialized global variable, and this one, the global, is the one initialized global variable. That the uninitialized global variable will be initialized with the value of 0 before it reaches the main function. We can see here, the global is initialized with 45. The uninitialized global is initialized with the 0. And the scope of this one, it will be available to any of the functions available here. For example, here we can able to see integer some function of void Then I am doing a print over here to YY to copy and print it here, and we can have it over here. Now I am printing this one with the function call. After that I am changing A to 40 and global to 30. Then I am printing again with the function. Now we will see that result /global. Yeah, now it's something like we got 45 0, 45 0, 30 and 40. Something like over here we got printed. We can able to, this global is the variable which we can able to access here in the another function. Also in the main function it can, basically the global variable can be accessed anywhere inside the program basically, and the scope of the lifetime of the variable will be available till the time the program get closed. It will be initialized during the program start, and it will be available till the program going to end. And here we can able to see that we are printing global. Here we are getting 45 and 0, which is initialized value, and we are printing that function that's also printing 45 and 0, since it will be accessed anywhere inside the program. And we are changing here A to 40 and global to 30, and when we are printing we are getting a value of 30 and 40 over here respectively. It's presents that it gives that whatever be the change at any part of the program, that variable value will get changed when we read back the value basically. This is the scope of the global variable. The global variable is the one which will be needed when we are designing or developing a program. The global variable should be made in such a way that there should be very less global variables, because it will take more space in the RAM, that it has to be reduced in such a way that, and also that in the global variable there should be a strict reason to make that variable as a global variable, so that you will save RAM and the performance as well. And the next one we can see about is the local variable. The local variable is the one which is declared inside the function. Its scope is within that function, must be initialized with the value before reading, and the initialization will happen inside the function. Basically that earlier we seen that global variable, that before coming to the main, that global variable got initialized. If view does not give any value, it was uninitialized 1, it was initialized with a 0. In case of local variable, it does not have any initialized 1. You must initialize that with the value before accessing or reading that, before using that variable basically. That initialization will happen inside the function only, it will not be accessible outside of the function. And uninitialized local variable may be any value, depends upon the program stack. For example, whenever the local variable, we are creating a local variable that will be allocated in the program stack. Whenever we are going out of the function, that the variable lifetime will be gone. That whenever we are coming back, that the variable will be allocated inside the program stack again. Since it was regaining in the programming stack, it should be initialized, and it may be any value, depends upon the program stack. Since it makes us to inconsistency, the best practice is to initialize the local variable before accessing that basically. Now we will see about that local variable. Here I am going to initialize that integer local. It should be initialized with 40, some value. I'm just initializing. I am trying to access this. Maybe I can take a different one which will give you more clarity. Local.c include stdio.h integer main integer or c comma character star or v. Return 0. I am making a function, another function, integer function of void return 0, and then I am going to use integer local. It's best practice to initialize it with the value, and I am going to print %d/n comma local, and I'm going to compile this. gcc hyphen o local.c /local. It gives 0 is the value. We initialize that local variable with the 0. We are getting the 0. For example, we can try. Shall we try to access from here? Yeah. What it says, something like in the function it was undeclared. For example, over here that we declared inside this main function integer local, and local will be visible within this function scope only. It will not be available over here. Basically, that its scope of local variable is within that function. It should be initialized. Whatever you are changing in the local variable will not affect over here. For example, here I am defining another variable, integer local equal to 10, and printing that, and I am going to use function, and then I am printing again that local here, and I am going to change it local to 65, and then I am printing again. Yeah. Now gcc hyphen o local dot c. When we run, we will get that something like cat local.c. Here, for example, we are coming into the main function, and local variable is 0, and we got the print of 0. Then we are calling a function called function, and in that function local is initialized with the 10, and we are printing that 10. Here we have to be careful that whatever we are changing in this local variable, that will be available till that function call ends. Here we are calling that function call ends, that till that time the local variable is 10. After that, when we try to print the local variable which is available for the main, that is 0. It will not get changed basically here. And when here we are assigning that local again with the 65 and printing it, we are getting the printf of 65, and when we call the function, this 65 will not affect over here, and it will be the same of 10 which is initialized. Basically here to confirm that the local variable scope will be within that function, even if you are having that in the variable in the same name in another function, that will not affect the different function. If for example in the function a you are having a local variable as a, and the function b you are having a variable of a again, then it both will not get conflict. both will be having the different lifetime within that corresponding function scope only. And basically these local variables will be used that the function needs the processing that has to be within that function. All that will be taken care used in the local variable, and global variable will be used, for example, that it will be the global resource which will be used by multiple functions. Then the global variable will be used basically. And here we have a static variable. Static variable can be defined as a global or and local as well. For example, if it is a global static, its scope is within that file. For example, it will be within that file, similar to that the local variable which is within that function. If you are defining a static global variable, then it will be within that file. You cannot access that variable in another file. Basically, it can be accessed within that from any functions of that file, but it cannot be accessed from the another file. Basically, here we can able to see over here. Maybe we can use the same file local.c. I'm going to use static global, static integer yes global equal to 40. Then I can able to print cp local.c is global dot c. Then we can use this global dot c as the one, and we can able to print. I'm going to print s global, and then s global static global yes global I'm going to print this gcc -o yes global dot c, and we run. We are getting that. For example, cat yes global dot c. Here the static global variable also will be initialized before the main function call. It got in s global variable got initialized with the 40 before coming to main, and when we print that s global, we are getting a 40 value of 40, and we are accessing that same s global variable using the function. When we print that s global variable using that function, we are also getting the same value of 40, and again we are printing that s global variable in the main itself. There is no change, the same value resides, and then we are changing that s global in 6 to 65 and printing that s global in the main function. We are getting the 45 value, 65 is the value we are getting, and we are going to print that same s global with the inside the function. Since this s global is global variable to both the things, and it has this here also we are getting the same value of 65 basically. For example, here we have how we cannot able to access, we will see. For example, I am having a function called sg1.c. in that I am just including stdio.heights and then integer fun void, and I am going to access that s global equal to 0. Now I am going to compile gcc-o and s global dot c, s global dot c and sg1 dot c. We are getting that error of s global is undeclared. For example, here we declared over here that sg1 sglobal is variable is declared here, but it will be within this file only. We cannot access this sglobal in another file sg1.c. For example, here if we make that static again, integer sglobal equal to 30 and printing that sglobal, printf %d /n comma sglobal, and we can call this function over here in the sglobal.c in the last. And we can able to compile. Implicit declaration, we have to give that prototype. That should not be problem. Maybe in that we can able to run sglobal. Here we can able to see cat sglobal.c. Here the similar way 40 40 65 initializing that static global here 65, and we are getting sglobal 65, and in this function or within this file that function also having the value of 65, but when we are printing that the variable here in the sg1.c, we are getting the value of 30. It's something like it got initialized with the value 30 over here in the function. For example, that sglobal declared in sg1.c is scope is within this sg1.c, and the variable the same name in the sglobal defined here, it also uses that sglobal within this file. This one, when you are printing the way accessing that sglobal within this file, this the within this file scope will come, and here when you are printing here or changing this value this variable will only get changed even in the same name, but it will be a different scope basically, and this it will be allocated for each file. It cannot be accessible by the both files basically. This gives that something like you can use the same name, same variable names, but different scope for the each file that we can able to define using this basically. And for example, you can also define that static variable as local, and we can see that what are the objective of the static local. Its scope is within that function. It will not be accessible outside, similar to local variable. It will access a local variable, but it can be accessed from that function only, and it cannot be accessed similar to local variable. Local variable cannot be accessible outside the function, and initialization will happen on first time execution. Basically, for example, you are defining that the static local variable inside a main function. Whenever that main function will get called for the first time, the initialization will happen. After that, if so similar to that global variable, if it is not uninitialized, it will be initialized with the 0. Basically, local variable, it may, as we discussed, local variable may contain inconsistent value. In case of static local variable, if for the first time when we call, it will be initialized with the 0 if it is uninitialized, or if we give that initialization value, it will be initialized. And we seen that the local variable, whenever we are going out of the function, the local variable scope will be cleared. In case of static local variable, the lifetime will be till the end of the static local variable will be accessed within that function, but its lifetime is till end of the program basically. Here we will see about that. slocal.c, I am going to use include stdio.heights and then integer main integer args gcc comma character star argv, and then I'm doing return 0. I'm going to change something like integer function of void. Within that I'm going to define the static local variable, static integer x equal to 40. I'm going to print percentage d slash n comma x, and then I'm going to do x equal to x plus 10, and I'm printing again. And I'm doing that return 0 over here, written over here, and I'm going to call this function here for the multiple times function, and then yypp, yeah, gcc -o slocal.c, and I'm going to print over here. You can see 40, 50, 60, 70, 80, like that it got incremented because here I am having that function. Whenever the function is get called, the x variable is initialized with the 40, and when I am printing it, we got the 40, and we are going to increment with the 10, and I am having the value of 50. Whenever I am coming back again with that function, and I got the value of the static local variable, the scope will be within that function, but it will not be, it will be initialized only once during first time in the function call. After that the initialization will not be happen, and the variable information will be completely available in the data stack. It's not in the completely available in the data area of the program. It will be retained till the end of the program, and when we are calling again and we got that 50, the value which we changed earlier, we got that, and we are incrementing again to 60, and whenever we are coming back again into the function, we got the value of 60 again, and we are incrementing to 70, and when we have got the value of 70, and whenever we are coming back again, we got the value of 70 again, and we are incrementing to 80. It's something like the static local variable. The x can be accessed within this function, but its lifetime is till the end of the program, so that it will not change locally. Yeah. And we have another variable called register variable. Register variable is used to store that CPU register instead of memory, inside the CPU register instead of memory. It provides faster access. Basically this variable will be used in embedded systems with the 8051 kind of microcontroller programming, and only few variables can be placed into the register. Since we have that for example 8051 has that only 8 registers, and we can have it, the few variables can be placed into this register basically, and we should use this variable very carefully in order to fit into that registers. Syntax of the register variable is register, data type, and the variable. Something like the data type will be common. We just need to add another one, register, which indicates that this variable should be placed inside the register, not into the memory. Since we have that limitation of registers, the processor registers, if we use more register variables, it will automatically shift it to the memory, and we does not have the control. We should use this register variable as limited in order to allow that compiler to fit that register, fit the variable into the register for the faster access. And we have another variable type called extern variable. It's just a declaration. It will not allocate the space. For example, we have the global variable, if you wanted to access that global variable from one file to another file, we have to use this extern variable. We can see over this here, and we have the global.c. it has defined with the global variable, and for example we can define extern.c. in that include stdio.h, and we can use extern integer, but the thing is, for example, global.c, it has the variable of global, and I'm going to use this same name. We should use the same name as extern if you wanted to use that, access the global variable in another functions. For example, here I am going to use integer func of void, and I am going to change this global plus equal to 30, and I'm going to printf %d /n comma global. I'm going to print after this one, and here we will be seeing, here we will be getting that value here. Maybe we can comment some other things. I'm going to access with the func, and then I'm going to access this variable with the function. Now when we compile gcc-o extern global.c and then extern.c, then we have that the implicit declaration. I can compile extern.c so that we are getting the value over here, and cat, I'm doing that cat global.c. here we are printing that function. The function global has something like global and a, and we can check that global here the 30 we are making, the initialized value is 40, 45 we are getting, and we are changing to 30 over here, and we are printing, we are getting that 30 and 0, and 0 is for a, and we have something like, when we are going into this function extern.c, over here we will be getting that whichever the value over here, the 30 we are getting, and we are incrementing with the 30, and it got incremented global. And when we try to access that global variable again using the function in the global.c, then we are getting the value of 60, which is incremented in the extern.c in the global. It provides that global.c can be accessible by any number of files, and it will be globally available to any of the functions in the program, and it will exist, its lifetime will be till the end of the program basically. And for example, to access that from one file to another file, you have to use extern keyword to access that the global variable to the another. Basically we can say that extern will give you that provide the access to the global variable into your file basically. Yeah, thanks for watching. You can contact me at nvhariharan@nivitech.com. Thank you. Subscribe for more updates. Thank you.